Okay, it's our final week. Woo! Announcements: no meetings for the rest of winter quarter. This is our last meeting, and we'll try to get a different meeting time next quarter. Maybe a different place as well. Who knows? But definitely, we'll try not to get Friday nights again. No updates on core utils. I'll try to figure out some code over spring break. I think last meeting we talked about like how to get started, like setting up your repository and how to like test the core utils functions or core utils executables. So you can try that out on your own. But next quarter I'll have some more specific updates on how things actually work. Hopefully. Any toy product updates?
No.
No. Okay, cool. Well, I hope the toy product has been enjoyable for any of you who have been like working it on your own. It was really interesting for me to see like the different Rust ideas and parallelism, in fact. And I was able to actually get toy products up to like 12 times performance, so that was pretty cool. Okay, so this week we're going to talk about a parser. So what is a parser? So consider the string starting here, A, star sign, asterisk, parentheses, B plus C, closing parentheses. Right, this format is pretty much unintelligible to an interpreter / compiler if you just like fed it in the string, because like it wouldn't know how to calculate, right? So that's why smart interpreters like Python will want to transform the string to a data structure that looks like this, so that it can actually do the computation. So first of all, the A times is done last, and the addition operation is done first. So that's why you see here in this tree, the addition operation is like the deepest node over here. And if you get it into this data structure, it's much easier for a compiler or an interpreter to just execute these nodes and then spit out the results instead of trying to parse a string. Okay, so this is like a basic application of a parser. Implementing a parser in Rust. We're going to be implementing a single match parser with no error messages, which means that its function signature looks like this. It takes in a string, right? All parsers need to take in a string. And what it gives you is the data structure that we illustrated on the previous slide. This kind of data structure, which is a tree, right? Notice that this data structure can be optional, and the reason why it's optional is because you can have invalid syntax. You can have syntax errors in your string. In which case it would return none. For return value of sum, AR means that the parse succeeded, where A is the parse value and R is the remaining string. So it could be that maybe there was like a plus D at the end over here. In that case, we could return this data structure, and then the remainder would be plus D, because we didn't actually parse that part. But usually we want to parse the whole thing. Usually we would want to parse the whole thing, but in some cases, there might be a remainder. And so here's some examples, right? So parse number 1, 2, 3, ABC. This gives us sum 1, 2, 3, and then the remainder is ABC. So in this case, ABC is not a valid number. That's why it's a remainder. And then parse ABC is none because there's no numbers to get out of it. Okay, so parser combinator. What is a parser combinator? Think of it like a function that combines parsers. Suppose we had parsers P and Q, right? So again, a parser takes in a string and spits out a tree, right? Then a parser combinator could recognize any string that is recognized by P or Q. So suppose P was this like arithmetic parser, right? So if P parse arithmetic, then P would be able to take in the string and then spit out this plus. Whereas let's say Q was this example, a number parser, then Q could take in a number and then spit out like some tree or whatever, spit out an integer. So then we can combine P and Q. So P again is the arithmetic operator parser. We can combine them to make something that can actually do arithmetic, like Python, right? We can recognize any string recognized by P and Q. Suppose like you had a language, a P recognized some language and then Q recognized some language, and then you only want to recognize the things that are common in those sets of strings. Then you would do that. And then recognize any string that consists of any string recognized by P concatenated with any string recognized by Q. So maybe you could say P recognizes a function declaration, and then Q recognizes the body of a function. And then you can concatenate those two to recognize a function, or if P recognizes a function signature and then Q recognizes the body of a function, then you can concatenate those two to recognize a function declaration, which consists of the signature and the body. Okay, sure. So that's combinators. Okay, well, why are we doing all of this theoretical stuff? We already solved the arithmetic example in CS32 using the shunting yard algorithm, which like deals with like stacks and stuff. But this idea is much more flexible, because shunting yard algorithm is only for like infix notation to prefix notation, so it can really only do like arithmetic. Whereas this, we can actually parse JSON, which is much more complicated. Is it much more? I don't know. It's more complicated than arithmetic. It has a lot more symbols, right? So we're gonna do this. So JSON, you have your objects, you have your keys and your values, and you also have lists. Lists or stuff can be nested, all that good stuff. And you also have numbers, right? You have strings, numbers, lists, dictionaries, and other. Oh, that's true. I forgot to put that in here. Okay, some loose ends. I guess some loose ends from all that theory talk. We actually need to figure out how to recognize the JSON grammar, because we recognize it like as humans. Like we can say, oh, this is valid JSON, or we can say, oh, this is missing a colon, or this is missing a comma or something. But how can we put that into a program? And then we need to define our tree structure, right? So like over here, our tree structure was arithmetic operators, the asterisk, the plus. But how can we do that for JSON? Well, I guess we could have open curly brace, closing curly brace, and stuff inside, but how can we represent that as a tree? And that's pretty much it. So let's start writing.
Should I just do screenshot this?
Maybe we could do like the VS Code like live share, code share, whatever, so we can all work on it.
Sure.
Do you know how to set that up?
Yeah. Why did I not sign into live share? It's what? Oh, actually, okay. I will send a live share in the chat. I was about to send it to the ACM cyber chat.
Oh crap! I forgot to edit the cyber video. Oh. Oops.
You were supposed to remove the.
Yeah, I was supposed to block it out, but I just
publicly
forgot to do
disclosed
that.
vulnerability.
Yeah. Wait, this is still